Alright, this video is going to be on Coulomb's law. And Coulomb's law is named after a French physicist named Charles Coulomb, and he figured out a way to calculate the force that exists between two charged particles. And so I'd like to go through Coulomb's law, and if the first thing that you should recognize with Coulomb's law is that it looks almost identical to Newton's universal law of gravity, that equation we just got through going over. But this equation here, so force, and a lot of people call it the electric force because it's between two charged particles. So force sub E is equal to K times Q1 times Q2 divided by the distance between those particles squared. And so K, I will always give you what K equals, but it's known as the Coulomb's constant. And K is equal to 9 times 10 to the 9th. And the units of K, to get it to work out, are newtons, meter squared, Newton meter squared, all over Coulomb squared. And so we'll talk about Q1 is equal to the magnitude of the charge on particle 1. Q2 is the magnitude of the charge on particle 2. And d is the distance between those two particles squared. And so you should recognize a couple of things here. As Q, as the charge gets bigger, what's going to happen to the force? Well, if Q1 or Q2 were to get bigger, the force, the electric force, would also become larger. Well, and by the same logic, if Q, the magnitude of this charge, was to decrease, so if Q got smaller, the force would also decrease, the force between them. Okay, and then because the distance between them is on the bottom here, you have an inverse square law, again, which we've just gone through with the law of gravity. But if the distance between them, so as d increases, so if the distance between them got further away, what would happen to the force? Because you would be dividing by a larger number, this force would go down. And so as charged particles get further away from each other, the force between them decreases. However, if you move those charged particles closer together, so if you decrease the distance between them, now this number is smaller, and you're dividing by a smaller number, so the force would then become larger. And so hopefully you recognize those relationships and how that kind of works with this equation. It's just like Newton's universal law of gravity equation that we just used. In this video, I'm going to go through a couple examples of how to solve Coulomb's law type problems and do the calculations. But I first want to I think it's kind of important with charges to review all the particles that make up an atom. And so if you remember back, an atom is made up of three particles. A proton, another particle that's in the nucleus with the proton is the neutron, and the last particle that makes up an atom is called an electron. Okay, and these, number 1 and 2, so proton and neutron, are found in the nucleus, and the electron's found in the electron cloud. It surrounds the nucleus. But what's important to recognize is their charge associated with each of them. So charge. This is their electric charge. A proton, I always remembered it started with a P, so it has a positive charge. So it's a +1 charge. A neutron is neutral, and so it has no charge, a charge of 0. And an electron has a -1 charge, so it's a minus or a negative charge to it. Okay, and we need to understand how these charges could interact with each other in order to really understand Coulomb's law. And so the first few slides here that we're going to go through in these practice problems are going to be reviewing how these charges interact with each other. Okay, if we look at this first problem, it says below are two protons. If they are brought together and released, what would happen? Okay, and so if we remember, A proton has a positive charge. And so if you bring two positive charges together and release them, what would happen? And because they are the same charge, like charges repel each other. And so they will move further apart. And so their motion would be something like this. And so the answer here is they will move farther apart. So again, like charges repel each other. Okay, let's look at number 2. It says, below are two neutrons. If they are brought together and released, what will happen? Okay, a neutron, if you remember their charge, a neutron is neutral. It doesn't have a charge, so its charge is 0. And so if you brought two neutrons together and release them, they will stay in the same position. Because they have no charges whatsoever, they're not going to be moving because of their charge. All right. Number 3 says, below are two electrons. If you bring two electrons together, what will happen? And remember, the charge of an electron is negative. And so if you bring two negative charges together and release them, electrons, they really don't like to be by each other because they have the same charge. So if you were to show their motion of what they would do, they would try to get as far apart from each other as possible. And so they will move further apart. And so your answer there would be C. Okay, number 4, it says below are below are an electron and a proton. If they are brought together and released, what will happen? So if we look at the charges here, we have an electron which is a -1 charge and a proton which is a +1 charge. And so now we have opposite charges, and opposite charges attract each other. And so if you looked at the motion of, if you release them, these two particles would come together. And so the answer here is they will move closer together. And so if we just review that one more time, like charges repel each other and opposite charges attract each other. So if they're opposite, they attract. That's kind of where that saying comes from, opposites attract. Okay, so a final review of charges here. Let's answer this question. It says, like charges will, so for example, if these two electrons were tied together, electron has a minus charge, because they are like charges, they want to repel each other. So they will want to move out. They want to get away from each other. And so like charges will repel. Opposite charges, for example on this one, where we have an electron and a proton, they will attract each other. They will move closer together. So attract. Opposites attract. Okay, let's go through a couple of examples of how to use Coulomb's law equation to solve for the force that exists between two charged particles. Okay, in this one, on number 6, it says a negative charge of minus 5.5 times 10 to the minus 5th coulombs. And that's another thing I should talk about, is the charge. The unit for charge is coulombs, named after Charles Coulomb. And so it's given a capital C to designate a coulomb. Okay, and so you have its negative charge and a positive charge of 8 times 10 to the minus 6 coulombs are separated by 2 meters. What is the force between the two charges? Draw the free body diagram and show the direction of the force for each charge. Okay, and I will always give you Coulomb's constant, which is K. So the first thing that I will do is to rewrite Coulomb's law. So that is the force electric is equal to K times Q1 times Q2 divided by the distance between them squared. Okay, so now we're just going to substitute numbers into this equation and plug these numbers in. And so we've got 9 times 10 to the 9th. And for the sake of space, I'm not going to include the units, but you need to be aware that the units have to be in coulombs and meters. And so if they're not, you'll have to convert them to those units. Okay, and for us, this first charge, and again, it doesn't matter Q1, Q2, which one you assign, but it's a minus 5.5 times 10 to the minus 5 coulombs And we're going to times that by Q2, which was 8, times 10 to the minus 6 coulombs. And that's going to be divided by the distance between them squared. And the distance between them was 2 meters. So I'm going to put 2, but we've got to square it. Okay, so if I put that in my calculator, you should try putting this in your calculator as well as I go through it. So 9 times 10 to the 9th times a negative 5.5 times 10 to the minus 5th times 8 times 10 to the minus 6th. Okay, and divide that all by 2 squared. And so I'm getting that the force between them is equal to a negative 0.99, and the force is always, the units of force are always newtons, and so, and that's what your answer will be. Okay, that's the force between them, but it also wanted you to draw the free body diagram of these charges and show how the forces, the direction of each force. Okay, so if this is Q1, let me put Q1 here, and this was Q2. Okay, Q1 had a negative charge, and Q2 had a positive charge. So opposites attract, and so you will draw your free body diagram with a vector pointing toward each other, and they will move toward each other because they are opposite charges. And again, the force of this, the magnitude of this force is equal to 0.99 newtons. Okay, one final example of Coulomb's law. Let's go through one more. Number 7 says a negative charge of minus 7.2 times 10 to the minus 8th coulombs and another negative charge of minus 4 times 10 to the minus 6 coulombs are separated by 0.5 meters. What is the force between the two charges? Draw the free body diagram and show the direction of force for each charge. Okay, so again, I'll begin by rewriting Coulomb's law. The force is equal to Coulomb's constant times Q1 times Q2 all over the distance between them squared. So let me rewrite it, now plugging the numbers in. 9e to the 9th, that's the constant, times Q1, which is negative 7.2, times 10 to the minus 8th coulombs, and Q2 was a negative 4 times 10 to the minus 6 coulombs, all over 0.5 meters, so 0.5. But don't forget to square that. Okay, and so I'll put this in my calculator. 9 times 10 to the 9th times a negative 7.2 times 10 to the minus 8th times a negative 4 times 10 to the minus 6th. And we're going to divide that by the distance between them squared, which is 0.5 meters squared. Okay, my calculator has given me that the force between these two charges is 0.01. If we round it to, let's see, 0.4. And that will be in newtons. And so that's the force that exists between these two charges. And you're going to notice that a lot of times with these Coulomb's law problems, the force is going to be very small when you're dealing with these types of charges, to the minus 8 and to the minus 6. So the force is going to be pretty small between them. Let's draw the charges. Okay, this would be Q1, and this one is Q2. And let's draw the free body diagram. Now notice that they were both negative charge, and so if you're going to draw the force vector arrow, two negative charges, they're like charges, so they repel each other. And so you will draw the arrow going in opposite directions. They are going to repel each other. And again, the magnitude of that force is this 0.0104 newtons. So anyway, that's how you would solve Coulomb's law problems, and how you plug them in and use that equation and to solve those types of questions. One final review questions of Coulomb's law that's very important to understand is this one. And number 8, it says, if the force between two charges is positive, the charges will repel or attract each other. And so if you look here, if the force is going to be positive, so if this is going to be positive, will the charges repel or attract each other? Well, there's a couple of ways the force will be positive. If you have two positive charges, a positive times a positive is also positive. And so the charges will, if they're the same, will repel each other. And so you'll notice if Coulomb's law is a positive force, those charges will repel each other. Also, if you had two negative charges, so if you had two negative charges, what's a negative times a negative? Well, it's a positive, and so your force will be positive. Okay. And so the answer to that first one was repel. Now let's look at this one. If the force between two charges is negative, so now if this force turns out to be negative, using Coulomb's law, the charges will repel or attract each other. And so if you had a negative force here, the only way for that to happen is if you had opposite charges. One has to be positive and one has to be negative. And then you will see that the force will be negative, because a negative times or a positive times a negative is negative. And so if you have opposite charges here, they will attract each other. And so you'll notice that if you use Coulomb's law and it turns out to be a negative force, the charges will attract each other. So I hope that's a good introduction to Coulomb's law, and I hope you were able to learn how to use that equation and to see how charges interact with each other, whether they attract each other or whether they repel each other. For your video physics assignment, I've got 7 questions that are going to follow, and they're very similar to the ones we just went through on this video. So if you get a little confused, don't be afraid to rewind the video, watch it another time or two, and see if we can't get it down. As always, if you still can't figure it out, if you still don't understand it, please stop by anytime. I will help you, and we can learn it together. But I'll scroll through them. Again, there's 7 of them, so stick around. I'll scroll through the 7 questions very slowly so that you have time to write them down. Good luck.